Welcome back to the channel. We have a very interesting Leetcode problem today. This is called Subsequence. It's a really neat little problem. So the idea is that you have two strings. S is ABC and T is something that contains the letters ABC in that order. You're supposed to return true if S is a subsequence of T. And the subsequence means exactly this, that ABC is contained in the target string. Like each letter is contained at some position, but it has to be in this exact order. Like A has to be first, B has to be second, C has to be third. It doesn't matter in which position in target they are, as long as they are one after another. If it's A, C, B in target, it's not a subsequence. So I really like this problem. How do we do this? Let's write it down. Let's think. So we have the source string. Let's just call it like the notation here is. So S is ABC. Then we have T is HBGDC. And then I suggest a string called result, and we initialize it to empty string for start, because this is where we store what we find. Like as we iterate these two strings, we are going to store what we find in the result. And at the end, we are going to compare. Hey, what we found is that exactly as ABC? And at the end, if result equals ABC, it means result equals S. It means result is a subsequence. So we return true. Okay. So let's do this. Let's say, so I think because the biggest iteration, the longest iteration that we need to do is on the target string. So we have like this: for every char in target string, which is this. And we are going to ask ourselves. So the first char is going to be A, right? And we are going to ask, is A in source? Is A in source? Yes. Then add it to result and remove it from S. We continue the iteration. Is H in source? No. Is H in source? No. Continue. Is B in source? Yes, it is. Is B in source? Yes. Then add it to result, remove it from source. It's to result, remove it from source. So that means since B was found in source, we add it to result, we remove it from source. And then we go. G. Is G in source? No, it's not. Continue. D. Continue. It's not there. How about C? Well, C is there. It's in source. It's the last character. And because it's in source, we do exactly this. We add it to result and we remove it from source. So at the end, we will have return result equals S. So we need to make a copy of this S, so that because we are going to keep modifying initial string or initial source string is ABC. So we want to return is result the same as initial source, right? So this is really cool, very simplistic exercise. And I think the time complexity will be O of target. Like you're gonna have to do only one pass for it's going to take as long, this algorithm is going to take as long as the target string is. And the space complexity, you're going to do all these operations in a constant time. So you have space complexity will be 001. Of course, please correct me if I'm wrong in the comments. Essentially, this is all just an extremely quick operation. This here, you add it to a string, you extract a character from another string. This is extremely quick. You're gonna have O of 1. So let's do all this. String initial source is s, because we want to be able to modify s. String result is string.empty, and we are going to do some stuff here, and we are going to return is it a subsequence, and a subsequence is just as we said, when result equals initial source, right? And now let's do these operations here. So we are going to have an iteration for. So what I said is that we always look at the first letter of source, right? We start with source like this. We start with source as ABC, and we start with the result empty, like here. And we always only have to compare the first letter with the current letter in T. So if S of 0 equals T of I, which is the current character that we are iterating, if this is exactly that, then all we need to do is to add it to the result, because that means we found it. Plus equals S of 0. We are going to update S to remove the first character, because we have found it already. We are no longer interested in searching it again. S dot remove, starting with index 0, remove one character. Yeah, we need to update this here. Yeah, that's all. Let's see how this works. Let's see. Yeah. Index was outside the bounds of the array. Ah, I have this error before. The problem here is that you can have the the scenario that the source string is literally empty. Like S can come empty. S can come empty from the data input from the test, and then you cannot just do, hey, S of 0. Who is S of 0 in an empty string? So if S is not string empty, oops, empty, right? Okay. Yeah, cool. So what do we learn? Well, I think the trick here is to, because initially I wanted to do like, I'm gonna iterate target, and then I'm gonna iterate again to look for every single character. So for target, for source, and that doesn't make any sense, because you only need to check the first character. Why do you need to check the first character? You don't need to check all the characters initially. Why? Because the description of the problem has a very important hint. And the hint is that you cannot disturb, like, subsequence is only a subsequence when you don't disturb the relative positions of the remaining characters. So always you need to search for the first character. As long as you keep updating the first character, you only need to search for the first one. This is why we remove it here, so that we can again consider the searching for the first character in the target string. Yeah, I hope this fun little Leetcode exercise was was as fun for you as it was for me. So yeah, I believe again time. So we do the computational complexity. Computational complexity. We have time complexity is O of whatever the length of t is here, and we have space complexity. Like the memory per each iteration is not going to increase. These are very quick to execute, so I would say it's constant. O of 1. Yeah, cool. Thank you very much, and I'll see you next time in the next video of Leetcode fun stuff. Please subscribe, and yeah, let me know if you have comments. Thanks. Bye.